Hi, this is Professor Chad McGuire, and welcome to this introductory overview on environmental law, including the concepts of environmental law. This is meant primarily for the environmental course that I teach at the university, but it's also, I think this is going to be one of about 13 videos in this area that broken down into different subjects and partial subject areas. So it should be beneficial to anyone who's trying to understand an overview of the concepts of environmental law, but I may reference materials in these videos that are specifically meant for the course that I teach in environmental law. As far as an introduction, we can begin by thinking that the very idea that we have laws in the United States and other countries, but specifically in the United States for the purposes of this lecture here, we have laws about the environment, and that in and of itself suggests that there's a need for these laws. We can imagine that there's a lot of things, a lot of areas, a lot of things that humans do, and a lot of areas where we have no laws because there's either not a need for any laws for, let's say, the protection of whatever those areas are, or that we simply have decided that even if there might be a need, that we've decided that we're just simply not going to provide any legal sort of protections or legal definitions or legal constraints on human behavior relative to those areas. So the first thing we can think about is that environmental law, it expressly suggests, more than implies, that there's a need to protect the environment. There is some problem that needs fixing, and that need to be filled by legislation, the creation of law, the expression of policy, if we're thinking about this from a sort of policy law standpoint, to alter either existing or future human behavior. And that in and of itself tells us something further. So the idea that we have environmental laws suggests not only is there a need to protect the environment from what we do, but then we can ask ourselves, well, how do these environmental laws come into being? Are they something that is an expression of we do things, these things have effects on the environment, and therefore then we decide after the effect to create laws to regulate our behavior? So in other words, do environmental laws generally follow the problems that we create, or I should say, do environmental laws come before? In other words, do we sit down and anticipate human behaviors and say, hey, there's this possibility that our actions are going to create some kind of harm in the future? It hasn't now, we haven't engaged in these actions, but as a preventative measure, we're going to enact these laws to protect the environment before we engage in any actions that might harm the environment. So we can think about not only the idea that environmental laws exist to do something to regulate human behavior in some way, but we can also think about when that regulation happens. Does it happen after the fact, or does it happen before the fact? Do we have laws that protect the quality of water, for example, after we've harmed water quality to the point that we need to enact laws? Or do we simply have laws that say, look, it's likely that if we keep going down this road, if we keep expanding in this way, if we keep developing in this way, then it's likely we're going to harm water quality, and that's going to have a negative impact on us in the future. So let's be preventative. Let's do this before. Let's enact laws that prohibit sort of a future behavior so that we never get to the bad result. We never get to harming the water. So we can think of it that way. So environmental law from this sort of like holistic perspective. Some of the questions we can ask from this conceptual beginning is, so if we do have these laws relegating to regulate our behaviors in relationship to the environment, what exactly is the environment, right? What is that? This thing we call the environment, what is it? And why does it need protection? So, are there other ways to protect the environment? Do we need to have specific laws? Can we just, people, can't they start, self-regulating? Would market forces simply, allow for, the environment to be protected at a certain point? So if you start spoiling something, if you start harming something, maybe that something becomes more valuable, and then market forces will simply transition and provide an opportunity to protect this resource that's been harmed or has the likelihood of being harmed. So do we need to have specific government intervention and specific creation of policy via law to protect the environment? So whatever that environment is, however we define the environment, does it actually need our protection? Another question is, do we have the capacity to protect the environment? So even if we can come to an understanding of a definition of the environment, and we can agree that it does need protection, whatever that definition is, and however we deem it needs to be protected, then we can ask ourselves, do we actually have the capacity to protect the environment? Can we do this? And if so, what are the trade-offs in doing this? So, right, if we decide that human behaviors are harming the environment and we need to protect that environment, or we desire to protect that environment, what's the effect of controlling those human behaviors? What if those human behaviors are incredibly important? What if they provide huge economic benefit for humans? What are the trade-offs effectively? So we can think about some of these sort of socioeconomic questions relative to environmental law. It's not a simple question of if we protect this resource, is that the end of it? There's been many examples, and without trying to get into too much detail, we can think about, for example, the Endangered Species Act in the United States. If we have, there was a lot of controversy in the late 80s and early 1990s about the northern spotted owl in the Pacific Northwest. This was an owl, a species of animal, a bird of prey that was endangered, and it tended to live in these areas of the Pacific Northwest that were valuable for many reasons. And some of it is old growth forest, incredibly important ecosystem services. But from a more sort of direct economic standpoint, many of these owls lived in areas that were actively being used by humans for silviculture purposes, for felling the tree, effectively just, harvesting trees. So for wood and paper purposes, and just the wood products, timber for building, etc. There was a lot of direct economic activity, and a lot of the industry in the Pacific Northwest at this time in these areas was directly related to the timber industry. So, the idea is, what are the trade-offs? If we protect the habitat, if we protect this bird, we need to protect its habitat. So what's the value of the bird? I mean, some would argue, and this gets into some sort of normative where we get into the values and reasons behind environmental laws, but some would argue that, a species is incredibly important and valuable, particularly if that species exists at the same time as humans, because it has all of these interconnected, this is the web of life, but interconnected effects on other species that then relate to the welfare and health of human beings as a species within that of life. Others would argue that, well, I mean, I don't know, it's maybe more, it's not as deep as that. It's a little bit more superficial. What are the bird watchers? How much money do they spend when they come to see this bird? How many bird watchers? Or, I don't know. It's something related to the direct economic value, not sort of the indirect or non-use values related to these species, but just more of a direct value. But you get the idea. We can start thinking about, even when we answer these questions, yep, we have a definition for the environment. We understand why it needs to be protected, and we have the capacity to do it. Even when all of those questions are asked, then we can start thinking about, well, yeah, but what are the trade-offs in doing this? Should we consider the trade-offs? Should environmental law think about the effects, the trade-offs? Should the policy behind environmental law think about these things? And the answer probably is yes. It certainly should think about these things. So let's think about environmental law from this large perspective. Let's begin to think about it from this sort of a very large, very wide lens. About our questions about what is the environment, is it something that needs to be protected, is creating law the best way to protect it, so on and so forth. Let's start there, and we can start working our way inward from there. So let's get an overview of environmental law, a general overview here. We can think about environmental law and break it into sort of the obvious. Environmental law must deal with at least two things: the environment and the law. So beginning with the environment, we can think about it from a number of contexts. Generally speaking, the environment is defined in a natural sense, and that means that it relates to natural settings primarily through observations and scientific study. So the environment, we can think of starting to get a definition of it. It's a natural place, maybe, right? And this is based mainly on objective criteria. Meaning the use of observations and scientific method inform us to what the environment is and how our actions might influence it. For example, to understand what we mean by this objective criteria or scientific method, observations of changes in carbon dioxide concentrations in the atmosphere over time have led to the detection of a relationship between increased average global temperatures and increased average concentrations of atmospheric carbon dioxide. These observations are the basis for understanding the background rate of carbon dioxide in the atmosphere, what has the actual concentration rates been in the atmosphere, the observed change. And when I say what has over recent, human scale times, let's say in the past 100, 200, 300,000 years, the observed change in atmospheric carbon dioxide concentrations, what's happening, how is it changing, and then the connection or relationship between increased atmospheric carbon dioxide concentrations and increased global average temperatures, which were also being observed at rates of change noted. The observations, those observations of those three things, background rate, observed change in atmospheric carbon dioxide concentrations, and any correlations, any connections between, well, when that happens, when we see more concentration of carbon in the atmosphere, do we see other things? Do we have an effect on other things? And temperature being one of them, global average temperatures. And how do they relate to one another? When one goes up, does the other go up? Do they have a positive relationship? When one goes up, does the other go down? Do they have an inverse relationship? So on and so forth. The observations are the foundation of the scientific method and allow for the use of objective information as the means of understanding our natural world, our environment. So that's what we mean when we're talking about environment. For example, climate change. We use objective criteria, the scientific method, to understand causal relationships that we find in this natural environment, the thing we call our natural environment. So that's one way of thinking about environment and starting to get to a definition of environment. From the legal side, from the law, breaking down those two terms, environment and law is really an expression of societal norms. And what that means is it's based on human preferences and capable of changing over time. So from a policy parlance perspective, in policy, we'd say that's an expression of policy preferences, mainly through statutes, as well as the implementation of those policy preferences, which would be the sort of enforcement, the administrative, or the executive side of things. So you would think of the legislative and the executive if we're thinking of branches of government. So an expression of policy preference via through passing law, right? The legitimation of policy through the legislative passing of law, and then the implementation of those preferences through enforcement. So we can see environment here defined mainly from a natural sense, and then law as the human side of things in terms of expression of societal norms, things we care about, priorities, etc. One way of visualizing this is the following sort of visual representation here. What we have here is we have three boxes, and we have the environment here in the green on the outside box, society listed in blue here, and then our economy listed here in orange. And so you can see from this image, the suggestion in this representation is that the law, which is represented here in the society, is constrained by the environment, here in the green. So we can see that our social institutions, we have our economic and, our economy, how it operates. We have our social institutions, which, are larger than our economic activity or encompass our economic activity. And then the environment setting the outer constraints. So again, our social institutions are bound by objective natural system factors. Thus, our social options are limited by environmental constraints. Our ability to make choices is limited by background environmental conditions. So one way to think about this is an example might be our ability to make social choices that result in the degradation of an important resource, like water for human consumption. I was bringing up water before, a drinking bather, etc. Potable water, kind of water that humans can use without risk of disease and that sort of thing. It's necessary for human existence and well-being. Thus, our social decisions are necessarily bound by their impact on water quality. If we allowed human activities to continually degrade water quality to the point where humans could not consume clean water, then we'd be placing ourselves into a position where our survival is at stake or at risk. Thus, our social decisions, the blue box, right, that might include activities that harm water quality are bounded. They're limited by our need for clean water. Background environmental conditions, the green, set the baseline for clean water, and our actions are then directed by a consideration of these background conditions, how much clean water is available, and the impacts of our actions on these conditions. So I hope that generally makes sense. That's the idea, is that the environment sets the limits. Our natural environment provides us with necessary limits. We can affect those limits. There's no doubt about it. Technological advances, for example, we can find water in places we normally couldn't. We can, dig deeper to find water under the ground. We can desalinate water, right? We can provide a number of technological advances that allow us to take seawater, for example, and turn it into clean water. We can certainly use reverse osmosis and, really high technology filters in order to filter existing river water and other sources of water to clean them from impurities. We can do water treatment. We can even treat wastewater. We can treat water that carries a lot of our waste material in a way that makes it we can do primary, secondary, and even tertiary treatment and further treatments to wastewater to make it clean for human consumption. So there's a number of things we can do to expand, but large scale. The water that is on Earth, whether that's water trapped in ice, water under the ground, or water readily available, is the amount of water that's generally speaking available to humans, generally speaking. And that generally creates our limits, the limits on, what we can do and the choices we can make. So we think about that natural environment in the green as being the sort of limiting factor, the ultimate limiting factor for the kind of choices we make. And our choices then affect our economic activities, of course, but our economic activities are bound by our societal institutions, the rules we make, our values, beliefs, and norms that change over time. And then those, including our laws and the execution of our laws. Do we want environmental laws? That's here in the blue. If so, what do they look like? And they are informed and constrained by the environment. So that's what this is meant to mean here. Another way, and I take this is, by the way, from my one of my books here, Environmental Law from the Policy Perspective. I want you to understand this. It's important because it's kind of how I look at environmental law and analyze environmental law. And the larger issues, the larger context is something that I'm always referring back to and starting from the policy context. So another way to sort of look at this is the law often, whether that be environmental law, any law, but the law is overlaid onto environmental issues after it has been identified and explored. So what I mean by that is often we want to understand the way that we sort of maybe want to contextualize our understanding of environmental laws. We really want to understand the environmental issue. And then we can think about how the law influences or affects or is affected by or is influenced by that environmental issue. Did the environmental issue create the law? Did the law come first and help to define the environmental issue, right? Are they sort of, what is the nexus? What is the connection? What is the relationship between the larger environmental issue and the law, the environmental law, for example, that we're looking at? It's really, I think, an important conceptual framework to think about. And the question again is, what do we look at first? Do we just look at the environmental law and try to understand it and understand its details? Or do we take a larger perspective? And what I'm saying here is that often we probably would understand the law better if we take a larger look at the environmental issue from multiple perspectives, from a larger, more holistic place, and then apply the legal frameworks in order to better understand that environmental issue in context. So that's what I mean by this sort of diagram here, is that the law sits within the environmental issue. And again, that's something that I talk about, and that's sort of the entire conceptual focus of that book I wrote, Environmental Law from the Policy Perspective. So that's kind of where my mind is at, and that's where a lot of our discussion sort of heads toward in this area of the way that I describe environmental law. So thinking about policy, this is important because what is the role of policy, just in lieu of what I just said? So in, the way that I look at policy, or the way that I introduce it, particularly in when I teach environmental law, is, Deborah Stone's policy paradox is absolutely, I mean, I think it's a must read for anybody who really wants to understand whether they are just involved in law, generally speaking, or if they're certainly in policy. They certainly should. But it's an incredibly important book for framing purposes. And so I use a portion, specifically her section on goals in the policy paradox, to help sort of frame the larger policy context related to environmental law. So one of the most important aspects, I think, from the goals section is the question of equity, because I think environmental law is really a question, the larger context for environmental law is a question about equity. It's about fairness. When we start thinking about in the environment, we really are thinking about the welfare, and sometimes this extends directly to human interests, and sometimes it moves beyond direct human interests into a larger conversation. We think about, for example, wilderness areas. Imagine we have laws in the United States to protect areas of our country, land, and all that's encompassed within that land, and the animals, etc. And we define it as wilderness. We've been doing this for well over 100 years, by the way. And that wilderness is not meant for, the utility. I would, you can sort of contrast or juxtapose it with forest land, national forests, right? So we have federal lands set aside as wilderness areas, national parks, for example, and in those national parks, including wilderness. And then we have other land set aside for, forest land. And a lot of forest land is used for, national forests are used for recreation and other purposes by humans, but they technically are meant to, grow trees, and then for the harvesting of those trees. That's what they're for. So there's this direct benefit. There's other uses involved. They are in, mountainous, generally speaking, relatively wild areas around the country, but they are meant to be used for direct human consumption, particularly growing trees and harvesting of trees. Writ large, known as silviculture, for those purposes. Whereas, we have other areas in our country that are just meant for the wilderness. They're just meant to protect those national parks, the actual character of the wilderness. And that goes beyond direct human uses. Certainly we get a lot of use out of that. We love to go recreate in these areas. We love to go just see them. And a lot of us just enjoy the fact that even if we never go there, that they exist. So there certainly are reasons for these areas to exist that connect to human values, our value system, but they're not, directly related to direct economic uses for humans, let's say, that sort of thing. That's not their intended purpose. So we do have laws on the book that really start speaking to larger goals. And of course, even the general goals, when we think about, clean water and things like that, right? We create laws and pass laws, clean air, clean water, to protect. And the question is, how are those protections distributed? Are they equal? Does everybody get, an equal share, for example? If the Clean Air Act is meant to lower air pollution, does air pollution get lowered equally everywhere, right? Or do we just cite, the things that create air pollution in areas that affect people of lower socioeconomic status, for example? So do our laws, the larger question in environmental law is, look, does this work? Yes, but how does it work? Does it work equally for everyone? Does it have, unequal effects over time? Does it, over space and time? Does it, is certain areas and regions more likely to, I don't know if you've heard of this, but there's so many ways to look at this. We think of land uses, LULUs, locally undesirable land uses, for example. Where do we put things that are, where do we put where we want to throw out trash, for example? Where are our dumps? Where do they exist? Do they exist in wealthy neighborhoods? Do they exist in poor neighborhoods? That kind of thing, right? Where does pollution fall? Where do we cite our coal burning power plants that have, dirty, lack of air scrubbers and dirty, sulfur and, heavy and other, sort of air polluting qualities that have direct effects on human well-being? Where are they cited? Are they cited in wealthy areas? Are they cited in poorer areas? You get the idea. So the question is, not only do we have environmental laws and what are they intended to do, but how do these environmental laws operate over space and time? You know, how are they in them? So Deborah Stone's section on goals really begins to talk about things like equity. And it's really important because when we think about policy development, the creation of laws, the legitimation of policy, but the larger picture is when we start creating these rules and ways of limiting human behavior, we have to think about overall not only what the intention was, the design of these things, but how do they operate? So often, most of us know this, right? There's an intention of doing something, and then the intentions often aren't fully carried through with the actual execution of the plan. And this happens in personal lives. We all have individual intentions, and then we engage in our actions, and the intentions and the actions aren't absolutely, you know, equal to each other. So this happens in policy and in law, that we have the intentions of what the law is supposed to do or the policy is supposed to accomplish, and then we have the actual operation and the results, and we can compare and contrast. And that happens all the time in terms of policy, larger national policies and examination of that. So what Deborah Stone talks about in this particular section that I have students read in my courses, fundamental questions for environmental issues include, in a world of limited resources, so if we just think about this larger scale question of equity, right? In a world of limited resources, so if we had a pie, Deborah Stone likes to talk about in terms of her, the equity is this pie, right? Slices of that pie. The questions we can ask is, who gets what? How are resources distributed and amongst who? So who gets these limited resources? Who's benefiting and who's not? Is everybody benefiting? Are they all benefiting equally? Is not everybody benefiting? Then if so, who's getting the benefits? Who's not? That sort of thing. Knowing who gets what, right? Who is getting what based on whatever criteria we might apply. When do they get their share? So another question we can ask is not only who gets what, but when do they get what they get? And then finally, we can also ask, how are these limited resources being distributed among those lucky few? So it's not just who gets it and when they get it, but how do you distribute? What criteria is established to divide up the pie? These are three profound, really important questions that if anybody's studying environmental law, there's always just the basics, the mechanics, getting the mechanics down, understanding the laws. What are they? How are they made up? And that is incredibly detailed and time consuming, and can take the rest of your life because they're incredibly detailed statutes and they're amended and updated and interpreted on a regular basis. So there are experts in the Clean Air Act, for example, that only study the Clean Air Act for their entire careers and lives. And again, the Clean Air Act changes over time. It has amendments, it has alterations, technological advancements, etc. Administrative rules interpreting the Clean Air Act, enforcements, etc. Different administrations running the EPA, for example, so many different things. So the Clean Air Act in and of itself can be just understanding it and learning it and knowing it in and of itself can be a lifelong endeavor. And we understand this. And you can really do a deep sea dive on just the mechanics and implementation of the Clean Air Act. What I'm saying is that certainly that's true. The Clean Air Act, Clean Water Act, all of these environmental laws are incredibly complex and detailed. But if we look beyond it, if we step back, there are these larger umbrella questions where all of these environmental statutes sit under, these larger policy questions. And Deborah Stone really helps us contextualize, I think, of some of these policy questions by talking about basic questions of equity. And that certainly belongs in the world of environmental law. So we can think about these questions. And just as a general framework, we can think about who gets what, when do they get it, and how are these resources distributed? For those of you that aren't taking this course that are interested, so if you can find Deborah Stone's Policy Paradox, I highly recommend it, and particularly the goal section and the discussions about equity. That's a really good sort of background that you might think about looking at if you really want to start understanding these larger questions. So thinking about policy is really important, but we can also think about and go back to this question, right, of what is the environment? We already said we look at generally the environment from a natural state, right? But what is the environment? So the environment is a term that can be defined in a variety of ways. Remember that natural, right? So we can think about the natural setting. So we think about the scientific method applied to the environment requires this notion of the earth. Think of the earth. Think of the Apollo mission, I can't remember, but being in space and our first vision in the late 60s, early 70s of the Earth, the orb of the Earth, right? So you have this idea of this finite, sphere sitting in the middle of this darkness. And within it, there is this environment, it's, some call it 21 miles, right? So the where we understand life to be, right? So just below the crust, just below the actual surface of the earth, right? Going so many meters into the earth, there's living things. Think of the bottom of the ocean and so many meters into the earth, top of the earth crust, all the way up to 21 miles into the atmosphere, the upper atmosphere. It's effectively where we understand life to be. And we think about that space as where there's life. So we think about life, the things that give, that help life. There's, of course, so many other things, there's the sun producing thermal energy, producing, turning hydrogen into helium, I think our sun primarily, right? But anyway, engaging in thermonuclear reactions and fusion, right? And all important things that give us, that help us in so many ways, because so much of our life is dependent on the sun, and then the cycles, heat, allow for, oceans, current. There's all these physics that are involved. It's a biogeochemical process. But if we think about just the biology for a moment, those 21 miles, and we think about the living things within it, we think about this natural setting, right? This natural environment, untouched by humans. That's one way of thinking of the environment. Another way, specifically for environmental law, or another variety of ways that we can think about the term in terms of an operational definition, we think about human health, public health. So we can think about the environment in a more sort of constrained way for environmental law purposes. And we think about human health, public health, air, water, chemical exposure. So that's a human orientation. We think about the human being's well-being as a sort of grounding element for environmental law. So we think about, well, the environment is in relation to. So environmental laws really should operationally define the environment as the things that are in relation to human well-being. So it's an environmental issue. It's something we need to think about when it poses a problem for human well-being. So we can think about that. And so what humans interact with most directly, it's sort of more of a linear as opposed to a more dynamic view of the environment directly related to human health. And we can then also think of this more scientific meaning that we already discussed, this larger, sort of less linear, less directly related to humans, which is more of an objective study of ecosystems. So you think of science just going out and trying to understand the interactions, the complex web of life that our world encompasses. And science is knowledge for knowledge's sake. So you're starting to understand, hey, how does this bacteria exists near thermal vents deep in the ocean, these hydrothermal vents that are incredibly warm, and the animals, even the crabs and some other organisms, sea anemones, etc., and tube worms and some other things, how do they exist in these really hot temperatures? It's amazing. Or the juxtaposition to that is, wow, we didn't realize that in Antarctica, under the ice, in incredibly cold conditions, deep, far below the ocean surface, there's a ton of life that exists there. And we didn't realize that these things could exist in these high pressure, super cold environments. And yet there they are. So this doesn't necessarily have direct meaning and relevance for human well-being, but it is connected, because when we start doing a sort of chain of causation, we can start seeing, once the more we know, we're like, oh, coral reefs are pretty, but they also provide incredibly important resources and many different resources, a lot more detail. But, geez, they're at the minimum, they provide safe haven for a lot of, let's say, target commercial fish species when they're very young. So the adults that we like to go after and eat, commercially capture and eat, when the adults spawn, they have these sort of nursery grounds that are near shore and protected, including coral reefs, mangroves, other sort of near shore areas, depending on what part of the earth you're in. And these very young, very vulnerable fish are able to survive by hiding in these, very protected habitats. There's nice little tiny things for them to eat. There's not a lot of predators. They can evade the predators and hide in the reefs, etc., much easier than they could in the open water. So what we start realizing is, just in this very simple example, is that, coral reefs, they're pretty, but they also have important relevance for human well-being when we start understanding that they provide habitat for the kinds of things that we like to go out and capture and eat. And if that habitat did not exist, then those things wouldn't exist. They would never, survive to adulthood. So there wouldn't be the next generation of adults to, create young, so on and so forth. But anyway, so we can think about it from only a natural setting, but human health, but also a more scientific or objective meaning, study of ecosystems, animal behavior, cell biology, etc. So we think about that in terms of the environment. So a term that can be derived in a variety of ways, but from the environmental law perspective specifically. So that's our sort of more policy orientated on the left here, what we just described. That's how we can do things. When we think about current US environmental law, the focus is on the human mostly. So most of our environmental laws, again, there's some like the Wilderness Act, et cetera, that are separate. I mean, they don't exclude humans, but most of the major environmental laws deal with human well-being. And in that way, operationally, they focused on this sort of priority, this range of priority when we think about the environment. So the environment from an environmental law, current environmental law perspective in the US, the highest priority, anything that is an immediate threat to human health. So we think about that second one on the left, human health, public health, air, water, chemical exposure. The highest priority is immediate threats to human health. And we have the Clean Air Act, the Clean Water Act, the Hazardous Substance Control Act. We have TSCA 2, the Toxic Substance Control Act, and which probably should be TSCA. But the point is we have a number of federal environmental laws that give highest priority to immediate threats to human health. Secondary priority. So we think about, so how do environmental laws exist? How are they written? And what are the major laws intended to do? We have highest priority, immediate threats. Secondary priority is things that support human health. And a good example there of a law that we'll look at is the National Environmental Policy Act. That's more sort of a general looking sort of, hey, before humans engage in, think of sort of a proactive statute, before humans engage in certain activities that can potentially have a negative effect on the environment. Let's take a close look at what those negative effects might be. So before we approve that major highway or that's going to tear down, so on and so forth of natural environment or whatever it is, let's take a look at what the effects might be. And so we think about those as sort of a secondary priority. Highest priority, immediate human threats to human health. Secondary priority, things that help to support human health. That more sort of like, hey, that coral reef might not be a direct support for human health, but the fact that it's habitat for bringing up the fish that humans really care about, yeah, that's important. Or, I mean, we can think about it for water purification purposes, et cetera, et cetera. And then the lower priority is environment for environment's sake. So we have environmental laws where we talk about, again, from the human grounding perspective, that are really directed towards protecting humans, that are also directed secondary priority to protecting the conditions that we think generally make things safe for humans. And then we also have environmental laws that protect environment for environment's sake. And here we have the Endangered Species Act, for example, which also is maybe secondary priority, but just sometimes they're lumped into these sort of, again, these are not set in stone. This is a dynamic, but anyway, we have the Endangered Species Act, the Marine Mammal Protection Act, MMPA, and also the Wilderness Act, which we've described before as an example. The idea of, well, humans are not immediately connected to the well-being of these things, but we think that there's connections there and they're important things. We've agreed as a nation, as a society, that they're important things to protect, but maybe not because they are immediately threats to human health, immediate threats to human health. So you can think about it from that perspective. What is the environment? Well, the environment can be defined in a number of ways. And then from the human perspective, how do existing environmental laws sort of rate from that perspective? How do they think about the environment? We can also think of the environment as a system. And this is really kind of important. So because it helps to define what we mean by environment and then how that operates in terms of why we have environmental laws. Where do they come from and what are they meant to do? So we think about this mostly when we say system from an ecosystem perspective. So what's important there is that the assumption is that the environment relates to that finite space, again, that orb of the Earth. And so we think of the Earth as a finite space because it is, but we also, this is mostly from biogeochemistry, but the Earth, we also think and understand is a well-mixed sphere where things do not change much at all in human timescales. One way that's expressed in chemistry and biogeochemistry is that the dC over dt, the change in concentrations of things over change in time. So the change of concentration of things over time equals 0. That just means that the Earth is like one of those snow globes that you've shaken up, and then there's a perfect moment where everything is well distributed. That snow inside the water of the globe is well distributed. That's what the current state of the Earth system is. That's not to say that the Earth has always been this way, but since humans have developed and evolved on Earth, have existed, and our precursors have existed, and us in particular, certainly for the past 10,000 years, the Earth, generally speaking, has been a very well-mixed system. And what that means is that you don't expect a lot of change. You can expect that the concentration of carbon in the atmosphere, absent humans taking it out of the ground and putting it into the atmosphere, is relatively stable. It does not change. There are volcanoes every once in a while that erupt and spew some carbon and so on and so forth, but those additions are minimal relationship to the overall size of the atmosphere and the current concentration of carbon in the atmosphere, and they are settled and taken up by other aspects of it's called the carbon cycle, where the carbon moves throughout from the atmosphere, deposition into the oceans, on land, into water, that sort of thing, and then ultimately getting buried from a number of plate tectonic activity, et cetera, getting buried deep into the Earth before it comes out very, hundreds of thousands, if not millions of years later, and we call those residence times. How long does a molecule of carbon sit in the atmosphere? About 100 years, before, naturally speaking, before it then moves to some other area. And then we call it stored underground. We find a lot of stored carbon underground. That includes the oil and coal and other things that we look for, that we actively go into the ground. If we did not do that, it would stay underground for a very long period of time, way beyond for human time scales. But that's, again, this system of the Earth, the way in which the Earth has been operating for a very long period of time, even though it changes over very, very long periods of time. But from human timescales, the Earth is a well-mixed system. It is a system that is basically the change in concentrations. If you're not mucking around and actively doing things to fundamentally change those concentrations, then the change over time is 0. That's really important, because if we see anything like climate change, if we see that we're changing that assumption of 0, we know that it's having an effect. We can look for those effects and we can say it's having an effect. But this really is the foundation of, and from an ecosystem perspective, when we think of the environment, it is an important foundation of environmental law, is this assumption of the change over time equals 0. So within that finite space, the space of the Earth, under human timescales, there are renewable and non-renewable resources. We can think about things that we can use for, that we have the technology and capacity to use right now, that are, relatively speaking, either renewable or non-renewable. And some environmental laws focus on ensuring the protection of renewable resources by controlling human activities. So water, for example, clean water. Clean water is a renewable resource so long as it's allowed to renew, so long as it's not used in such a way, or turned from clean, call it clean, but clean relative to human consumption, let's say, safe for human beings, right? We'll just use clean as the word to understand that, because clean is, all of these are normative terms. They all require their own definitions, but from let's call it for human consumption, we can take, there's a limited amount of available water for human consumption. Once we've consumed or used that water, we turn it into a state where it's no longer viable, easily viable for human consumption. Without additional work, there are natural processes that would then take that water through a number of cycles and processes that would then ultimately result in, relatively speaking, that same water now being, again, over a very a period of time, being available for human consumption. Once again, natural filtering processes, etc., that sort of thing. If anybody knows how a natural septic system works, I mean, we can have septic systems set up that we allow the things we don't like from our waste products to settle out, and then a lot of other things to percolate up, and then the water to move through natural filtration, natural sand, natural stone, a number of sort of natural filtration processes under the just under our land there, and the water gets to a point where it's very, relatively speaking, safe. It might not be as safe for human consumption, but it's much cleaner than it was when it first came out. That kind of thing, these natural processes that allow for ensuring activities. So this is, when we think of environment as a system, just another part of that process. And all of this stems from thinking of a finite Earth. The key is that the Earth is finite, it's not infinite. And then considering its interactions from a systems perspective. And most environmental laws develop from this premise. That's really important to know. Most of what we do in terms of our attempts to protect the environment, whether that's after we've done something we don't like, and we've realized it has really bad ramifications, or something we do like, but it has negative externalities, it has negative results, or we've thought about it and said we're going to enact laws to prohibit us from doing things that are going to be bad for us. Either way, all of these environmental laws pretty much all of them stem from this premise that the Earth is a finite space and under a systems sort of thought process. This is an example that I use to show very basic system, because people ask, well, what does it mean to be a system? So a system just means that, and the change in concentration over time equals 0, dc over dt equals 0. What we're saying there is that, look, the Earth this is like the Earth. This is like a general system where these are permeable, but they're semi-permeable, sort of the external part of the Earth. Think of the upper atmosphere as an example, right? There are things that move into the Earth, like sunlight, for example, and other sort of hydrogen, right? Hydrogen leaves, and other heavier hydrogen, I think, is our lightest, right? It's a weight of 1, but so very, very light elements can leave, other elements come in, that sort of thing. So, the boundary of the system may be either open, permeable, or closed, non-permeable, right? So we have also this, well, either, but generally speaking, when you think of systems, right, we say it's a closed system, even though we understand that still things come in and things leave. They're not much, but most of what's in the system stays in the system, and that's certainly true for the Earth. And then we have energy flows and interactions between components. A better way maybe of thinking about this, or seeing it as, is that when you have a system, that system sits under some state of equilibrium. That's what a well-mixed system is meant to mean, is that the Earth is for human timescales, at equilibrium. It's generally speaking, dc over dt equals 0 means it's at equilibrium, generally speaking. We know that, one of the things that you can do is that you can add stress to a system, and that stress can create change. If this is the system over time here, right? If this is the state of the system, it's at equilibrium, that stress can have an effect on the system. And there's often, systems have what's called thresholds. If you make a change to the system, a stress on the system, right, but it doesn't hit the threshold, then there's the opportunity for rebound, and you have a recovered equilibrium. So it comes back to where it was before. But you can also have such a stress on the system that it moves the system past its threshold point, which means effectively that you've achieved a new equilibrium state, as opposed to being at the original equilibrium. Because you've moved beyond the system threshold, you now are at a new equilibrium state. So imagine a world where the average temperatures of the globe don't vary more than 1 degree, Celsius, but then you have a new world where average temperatures vary X, 2, 3, 4 degrees. Fundamental changes. It seems like a little bit, but then it creates this new equilibrium state. And that new equilibrium state means that, look, you still get 100 inches. You still get, 100 inches of rain a year in that area, except instead of it falling over 250 days, it falls over 30 days. So you still get the same amount of rain, but the events of the rain are shortened in duration. Many less days of rain, longer periods of drought, for example, and then extreme amounts of water over shorter periods of time, shorter days, less days of rain, but lots and lots of water on those days. That's one example. You can just, and you have so the point is, climate change has got to be the best example where we worry about the Earth system. We worry what we're doing here. This is where, how far can we go? Have we gone this far? Are we beyond the system threshold, for example, and moving to a new equilibrium? Or will we give ourselves the opportunity to either, to limit the amount of carbon that we move into the atmosphere? And will we allow a system rebound to happen? Maybe it doesn't rebound all the way, but it gets much closer to here. The world that we understand and expect, that we've, become used to, that version of the world, or a world that's fundamentally different in many ways than what we've been used to. And then, of course, the question is, what does it take to protect, right? I mean, what's the cost involved, and maybe opportunity? Maybe there's zero cost, maybe the cost is negative, right, because of technological advances in renewable energies, for example. And then what is the cost involved in moving further in this direction? So that's a good sort of overview of environment. As far as final thoughts, when we consider the environment, we must have some understanding of what it is. We have to just have a general understanding of what the environment is. Come to some mutual understanding. Without having that understanding, you're really sort of lost, because now you're just looking at sort of these individual statutes, and you can maybe infer what their purpose is, but you really can't get a strong sense of, you can't, it's not relational. It just exists onto itself. You're looking at it in isolation. And I think that's one of the problems with how environmental law is understood, or at least taught in most environmental law courses. It's necessarily so, because again, it's such a vast area in and of itself. There's just not enough time. But the difficulty, particularly in law school, is that you want to understand the statutes and the case law, interpreting the statutes the best you can, and there's a limited amount of time. But again, the problem is that you really don't get a sense of what is the environment. So what we're really trying to do here in our introductory overview is to get a strong understanding, at least open up and explore, start to explore the questions of what is the environment, have an understanding of what that is. And there are many possible definitions in both policy and law, as you have seen through this introduction, hopefully. Once we have a working definition of the environment, then we can begin to think about how that environment, its benefits and costs, right? How that our own definition and related benefits and costs are to be distributed. Think of the stone in terms of equity. How's the pie divided up? What does the pie look like? Who gets what? When do they get it? And how do they get it? With policy in mind, with a reason for human action, right? So once we have all of that, then we can start to think about, well, there's a reason humans should do something about either limiting their actions after the fact or before we take action relative to the environment. We then give life to that action by creating law, policy, legitimation. So we can think about, where does environmental law come from? It's a definition. We need to know what we're talking about when we say environment. We need to know what the priorities are. We need to know how it might be distributed, the effects. And then once we know all of that, then we can start giving it real life by creating policy relative to that question or issue. And we can call that environmental law. And environmental law, thus, is the culmination of human decisions about the definition of environment, how we define the benefits and burdens of that definition, and how we distribute those benefits and burdens. That is it, everyone. I thank you very much for your time, and I look forward to having more of these discussions with you. Again, this is the first of maybe 13, I think, videos in this area. So I hope you enjoy it. Thank you.